Hi everyone, something a bit different today. I'll be doing the Codeforces Division 3, round 847, and let's go. It always takes ages to load in Codeforces, even worse than LeetCode, so that's always very fun. I think this round had like 7 problems or something. Okay. Hopefully that submits correctly. Yeah, I feel like the main reason I can't get like sub 1 minute stalls is just because of loading time, which is really annoying. Wait, how's it? NSR. Fine range. Okay, that was very slow, but hopefully that's fine. Four, two, one, three. Is that AC or not? Like, I can overkill this very easily, and I think I'm going to go. I think I will because it's really easy. top sort. Or is it graph.order? Okay, let's submit that. C on problem B. Time to read problem D. Did I get submitted or not? Okay, it's running. Okay, submit that. AC. The operation is there. Okay. So we know two numbers, and we need their bitwise OR to be equal to their sum divided by 2. Let's just look at some of these strings. This is actually semi-hard. I should also read some of these problems. Oh, it's XOR. I thought it was bitwise OR, in which case it was trivial. Okay, that makes it a bit harder. I see. Vertex is white except for one is black. Set to white vertex, white and black. The main difference between all pairs of different I see. Okay, let's get back to this problem, and I'll have to work this out on pen and paper, I think, because yeah, I'm not seeing the other obvious algorithm. So I need to figure out when it's impossible as well, because sometimes it's impossible. So I'm not sure if we're going to do the division with that. Oh, without rounding, yeah, okay. So an immediate condition is that it has to be the number has to be even. Why isn't the 6 possible though? I'm not sure how to do this yet. So often when this happens, sometimes it's easier just to brute force stuff in Python and just brute force stuff and see if I can spot a pattern. If I let's see if I can spot a pattern. 2, 4, 8, 10, 16, 18, 20. It seems to jump a bit. It's like runs, which will work. The pattern might be that the ones aren't adjacent and it's even. That's what I suspect the answer is. If okay, my guess is correct. Oh, it looks like I can just print n over 2. Okay. This is fine. Guess n. I just brute forced a pattern, which is one way to do it. Yeah, let's submit that. Yeah, that's probably fine. So I need to add a node and see what's the nearest marked node. Yeah, accepted. There's only F and G, so maybe I should read problem G. So I'll check the standings. Oh, I'm ranked 5th. Nice. Move one piece to adjacent vertex. Okay. Why does this one say jump? I don't know what once per turn means. Like, it's not well written, honestly. I wonder if I can do this offline. So for each node in every subtree of that node, determine the highest children. I can do this as centroid decomp, but do I really want to? Yeah, I think I do. See this problem. I'm just copying from this problem because I implemented it recently and I know that the centroid thing is here. I'm tempted to not modify. Like, I know I'm computing extra information, but it's just there already, so. Alright, remove the ice false. That can be a vector. I don't know what. I can't remember what a lot of my variables are. That's the only problem. Okay. Oh. Okay. I still do want this to be centroid though. ND. Oh, okay. Here. C's. and icentroids. Let's dive for depth rest. Okay, so it's time to debug this. Yeah, so somehow I'm getting negative depths. Let me just print the depth array to check this works. Okay, I'm convinced by the depth array. I think I don't need paths at all. Let me just delete that. Okay. Now what do I do? I'm just deleting some ugly parts of my code, honestly. I haven't yet figured out what I'm actually supposed to be doing. Oh. Okay, I take this back. I actually do need this to be distance. Let's just like delete some parts of my code I no longer need, because I realize I don't actually want them. Where's the list main I? Okay, that passed samples, so that took way longer than I would have liked, honestly. But Hopefully that won't bug. And now let me try to understand problem G. At the beginning you can make one move. They like use the words move and turn, so I don't know which one's which. Okay, F got accepted. So there's only this problem now. Now, that was so slow, so I definitely... Ooh, I'm still fourth. Okay, not bad, not bad. The vertex number 1 is the you can use different bonuses. Several. You can move the 8th to the 6th, 7th to the 5th, 6th. I do not understand this problem. I really don't understand this problem. Number of tokens. Number of So in this one, there's a token on node 2, and I can just go from 2 to 1. I can leave the game, I can move any P stages and then if. I don't understand what turns are. Is one iteration of this considered a turn? Like, this just doesn't make sense. Like, it's really bad. Take turns. Yeah, like this problem just doesn't make any sense, I swear. Like, they could have written this in much better English. I have no idea what more than once per turn means. I just want to ask clarification because I don't understand. Yeah, I feel like turn is one iteration. But I don't know how you would use something more than once per turn. That doesn't make sense. Like, I honestly have no clue what this problem is supposed to mean. Why is this jump? Okay, I bet someone solved it though. Yeah, Torres solved it. I just have no clue what this problem means. I don't know how to ask a clarification, I'll be honest. Oh, you can make multiple moves. I don't understand this. Possible to hit it with any token. I feel like they interchange the words move and turn so much that I don't understand. Okay, I'm going to try to ask a question about G. Hmm. Okay, this is my first time ever asking some question, just because I don't understand this problem, and I feel like being handicapped just because of how they wrote it in English. I can feel my time bleeding, but I just don't understand. How does everyone else understand? I feel like I've read this problem so many times. You can make exactly one move. The movement of the token. I feel like I'm coding up a problem which I have no idea what it is, which is so frustrating. Like, I'm just going to go for it and just like try to guess something. An MPB. And then the next one's other tokens. Then the next line, other bonuses. Loopable. Then the next line is edges. if there's exactly if like p equals to 1, I use this one token, let's just do a BFS. Okay, that looks roughly okay. Okay. Move equals 10, how bad? Okay. If bonus j reach I. That didn't answer my question at all. Not really. Sig abort. This is my usual strat. I like binary search to see where the error is. Should it be just easy just to use return statements? Boo J. Wait, it actually got AC. Yeah, wrong answer on test 2, but that's not surprising just because I don't understand the problem. Like, my code will work for the samples because the samples is so weak, but otherwise I just don't understand the problem. Okay, first of all, let me just clean up my code so that's easier to understand. We still haven't, like, explained. I have no idea what this line means. That's the problem. Oh, I see why I'm wrong, at least. Okay, now let's try to figure out in big, small, int I tokens, distance. Big and small, and flippable. might take a lot of attempts. Yeah, wrong one sometimes too. This might take like a huge amount of attempts, honestly. Okay, let's try. Number of tokens left, number of bonuses. Indices where the tokens are located, where the bonuses are located. Oh, what is this? My code was like completely wrong. Sorry if I've been in silence for a bit. Ooh. That looks like it's AC. Okay, AC. Let's look at how I've begun. Yeah, I did slip down to 8th, but I did beat people like Geothermal, so not bad. I did have a very good A to F, so overall I'm still pretty happy with how I went, even though I'll probably slip down a bit more. Now that I've gotten this far, I guess I'll explain my solutions to the to all of the problems actually. Yeah, I had a really good A to D, and then everything else wasn't as good. But I guess I'll go through my solutions. Okay, problem A is a straight implementation problem. It's just simulate exactly what the problem statement said. So luckily, because one of these strings has a length 30, and we only need to know the first 30 digits, we can just use this string. And all it's asking is, what is the length of the longest common prefix between the given string and this string of length 30? So in my code, I stored the 30 correct digits. Then for each character, If it's the correct character, then I'll increment the answer by 1. Otherwise, I will stop and just print the answer. Not much to say here, and I suspect almost everyone would have solved that anyway, so I won't waste too much time. Okay, in this problem, we note that we can work out the maximum dice value. The maximum value of the dice is exactly equal to s subtract r, s minus r, because when we removed the largest value dice, the total sum fell from s to r, which means that the value of that dice must be s subtract r. So in my code, first m is the maximum dice value. And what my code does is, so essentially what we need to find is, we need to find n integers between 1 and 6, such that the largest of those n integers is exactly equal to m, and their sum is equal to s. That's what we want to do. So the way my code works is, first we will just assume every dice has a value equal to m. So every dice has a value equal to the maximum dice, and then we will subtract, we will decrement the value of some of the dice. For example, let's say we know that let's say we know that the maximum dice value is 4, and we know this maybe let's say there's 3 dice, and we know that this sum, which is s, has to be equal to, I don't know, 7 or whatever. Maybe s is 7 and r is 11. So the first thing my code does is, based on r and s, s and r, is this the other way around? Yeah, this is the other way around. Okay, maybe this sum is 15 and it becomes 11 or something. Okay, let's go with 11 and 7. So we know that the maximum dice value is 11 subtract 7. So what my code does is, initially we just assume that every dice has a value equal to 4. Then we just need to subtract, we need to decrement some of these numbers until the sum of this list is exactly equal to s, which is 11. So since what my code does is, maybe let's use different numbers. Let's say 9 and 5. Say 9 and 5. That means that since the current sum is 12, I need to subtract 3. I need to subtract 3 from these numbers, decrement these numbers 3 times. And one solution would be 2, 3, 4, because the sum of these numbers is 9, and the maximum value is equal to 4. So how does my code do this? Well, the first thing we need is, we need to make sure that the maximum dice value is exactly equal to 4. So we will just take 1 dice away, and we won't touch this dice. We will leave this dice alone to make sure that the maximum is 4. And then all we need to do now is just subtract 3 from the remaining dice. So you can just do this fairly naively. For example, if you need to subtract 15 from 6 things, you just subtract 2, 2, 2, 3, 3, 3. I.e., from the first dice you subtract 2, from the second dice you subtract 2, 2, 3, 3, 3. This is pretty easy to calculate. What you can do is just do 15 divided by 6. Floored is, first you can find the floor of the fraction 15 divided by 6, and that gives you 2. And then we need to subtract 15 mod 6 more, so we just choose 3 numbers and subtract them 1 extra time. That's pretty bad explanation, but hopefully this makes sense. T is the amounts that we have to decrement, and then for the first n take 1 elements, we subtract the floor of that fraction, and then for just a little bit more, we subtract 1 extra. Some of the dice might be subtracted more, 1 extra than the others. I'm not going to waste more time, because I suspect most people would have solved that problem and wouldn't pay attention to this explanation anyway. Problem C, there is much simpler ways to solve this problem, but I had a template which solves this problem instantly. The way my template works is, mine actually uses topological sort. So I have a graph with n nodes, and if I have the sequence 4, 2, 1, I know that the number 4 goes before the number 2 in the list. The number 2 is before the number 1 in the list, and the number 2 is less than the number of 3 in the list. And basically for every adjacent pair of elements in any of these sequences, I know that the first one occurs somewhere in the permutation before the second one. And in my graph, I represent that as adding a directed edge from the first value to the second value. I.e., in my order, I know that the 2 must come before the 1 somewhere in my answer, so I add an edge from node 2 to node 1. And then once I've added all those edges in, I just calculate some topological ordering, and that's my unique permutation. Hopefully that makes sense to everyone. So this is just my code. I just have a top sort struct, and then for every adjacent pair, I just add a directed edge. Then I calculate some topological ordering and output that. Hopefully that makes sense. This problem is some greedy problem. The idea is we can just sort the dolls from smallest to biggest, and smallest to biggest, and then whenever we process a doll of a current size, if there's like a stack of dolls which has the maximum size of 1 less than it, then I can extend that stack of dolls. What I mean by that is, like, let's say we already have the sets of dolls like 1, 2, 3, and like 3, and maybe like 3, 4. If I'm processing a doll of size 5, since there's already a stack that ends at 4, I might just as well extend that stack and add this 5 onto the end of this set. But like if I was processing a doll size 6, for example, then I couldn't add this 6 anywhere on, so I would have to create a new set. That's all my code does really, is I just sort all of the elements, and T is a multi-set which contains the last elements of every set. And then when I process the doll of a current size, if there is a set which largest doll where the size of the largest doll is exactly equal to I take 1, then I can extend that set by adding in my current element, and otherwise I just have to create a new set. So that's what my code does. Like you can imagine, like if I take 1 didn't exist in this multiset, I would just add it to the multiset. Otherwise, I would replace that stack with my current set. Sorry, and then the answer is just the number of sets. And I do have to use multi-set, not set, because there can be multiple sets of dolls with the same largest doll size. Okay. This problem is an infamous example of just like guess the pattern, I guess. Spoilers, the answer is a node is valid if and only if it's even, and if you take the binary representation of the number, the substring 1, 1 does not occur. Like, I actually do not know how to show this. I know how to show that n must be even, but I don't know how to show the second condition. If you look back earlier on my screencast, you would have seen that I wrote a naive function to check whether a function can be written in this form, i.e. a and b do exist. And then I just tried to find a pattern, and since this is to do with binary stuff, I just outputted the binary numbers. And just by looking at which numbers are good, I worked out that this was probably the answer. And the construction for a and b I found was to take n over 2 and n divided by 2 times 3. Again, I just in my brute force solution, if you have a look, it did just print this, like, I just asked it to print some solution, and it just happens that for every solution that my program found, it was in this form, which made the thing really easy to guess. So this is a very, like, non-formal, you wouldn't be able to, like, I didn't prove anything, but it's good enough for our purposes. And I tested this from all numbers from 1 up to 1000, so I can be fairly sure it's correct. Okay, let's just check where I am in the standings. I will fall down. Oh, am I not going to fall down? I guess I'm going to get maybe 8th place. I'm still a bit upset because I could have been like 4th or 5th or something, but I'll still take it. Okay, my code for F, like by the time we get to F and G, I should probably do actual explanations. Okay, so this solution assumes familiarity with centroid decomposition. If you're not familiar with centroid decomposition, well, I'm not aware of another solution, but I am almost sure that some other solution does exist. I just haven't thought of a non-centroid decomp solution before. And also I already had code for centroid decomposition. So if you don't understand centroid decomposition, I guess I recommend you go learn that first. It is pretty useful, but not if you're a complete beginner, I guess. I think it's quite you won't need to know about it unless you're like a candidate master or above. Which means that since this is a Div 3, I'm almost sure that I've overcomplicated this, but whatever. Okay, so I'm assuming that everyone listening right now does know what centroid decomposition is, and there is a property of centroid decomposition that, if you so there's this things when we're doing our centroid decomposition, at any time we are recursing on some connected component, and what our centroid decomp does is, what we do is we find the centroid of the current component, and then we take the centroid, we remove all edges involving that centroid, and that splits our current subtree into multiple other subtrees, and then we recurse on those subtrees. And I guess this is medium poster which explains this significantly better than I do. Yeah. So the path from A to B can be decomposed into the path from A to LCA-AB and the path from LCA-AB to B. And what this means is that if you build the centroid decomp tree, and you get a set of all pairs of a node and all of their centroid ancestors in the centroid tree, if we get this set, then any path in the original tree from A to B can be expressed as a path from the node to the LCA of the two nodes in the centroid tree back down to the second node. I did have to give a centroid decomp lecture recently, so it is embarrassing that my explanation is so bad, but essentially I hope everyone knows what the centroid, if we get when we're doing our recursion, we'll have a function which recurses on some subtree, and what we do is first we take this, we calculate this centroid of the subtree, and then delete all edges involving node C. Then for all new subtrees, we recurse on that new subtree. This is how centroid decomposition basically works. And what the claim is, if we have some set, and then for all nodes in the subtree, we're going to add the pair from the centroid to every node in the subtree. Then this set of this is basically the set of important paths. I guess you should probably read this article to understand. But the key observation is that my implementation has centroids, which is some map. Centroids node dot append. If we get the list of all centroids of all of the centroid components that a current node is in, what I mean by that is for all ancestors in this centroid tree, if we want to represent the path between two nodes in the original tree, nodes 2 and 11, that's equivalent to going through the centroid tree, taking nodes 2 and 11, calculating the LCA, which is in this case 3, And then this represents the path from nodes 2 to node 3 to node 11. And if we look back in the original tree, indeed the path from nodes 2 to node 11 does go through node 3. That's what I basically mean. So one smart way of getting the distance from node 2 to like any other node, is to look at the centroid tree, start at node 2, and then for every ancestor, if we calculate what it's like, if we calculate some aggregate for each of its descendants, then like we can just query like if we were to go up in the centroid tree and then like down to its descendants, we would be able to reach every node. And so what I'm essentially saying is, for every node we store its distance to all of its ancestors in the centroid tree. So for example, for node 6, we would store its distances to node 11 and to node 3. And then if you wanted to get the distance from node 6 to node 2, that would just be the distance from 6 to node 3 plus the distance from node 2 to node 3. And we can pre-calculate all of this information. Now, how does this help us? Well, what we can do is, if we pre-compute for every ancestor which of its descendants is closest to it, and in the context of our problem, I'm basically storing for every node in the centroid tree at any point in time, I am storing the minimum distance from the current node to any node in its subtree in the centroid tree, which is black. For example, if we look at this subtree of node 7, if only nodes like 10 and 8 were black, then I would store the answer 1 in this subtree, because out of all of the nodes in the subtree, node 8 is the black node, which is closest to node 7, and their distance is 1. Now, if we want to know, for example, if we wanted to know the distance from 12, if we wanted to know the distance from 12 to the closest black node, which definitely passes through node 7, I would just look up the distance from node 12 to node 7 and add on the pre-calculated value for node 7. Wow, this explanation is not going very well at all, but yeah, I guess I'll try to work on this explanation. Essentially, essentially for every node in the centroid tree, I store the minimum distances to any of its descendants in the subtree in the centroid tree, which is black. And then when I want to answer the query for a given node, what is the closest black node, I look up all of its ancestors in the centroid tree, and I calculate the sum of the distance from the current node to its ancestor plus the pre-calculated value from the ancestor to its closest descendant. And that basically solves the problem. Like, if you look at my code, centroids D is like a list of all centroids, which D is is part of the component of. I.e., like, when we're doing our centroid thing, whenever we process the current centroid equal to V, like for every node in the subtree, I add V as one of the centroids, as an ancestor of the node in the centroid tree. And then when we are like trying to when we are like processing a new marked node, basically whenever we process a new marked node, we need to update the answer with the minimum of the current answer and the minimum distance from the current node to any already marked node. So basically, like, best x is the min distance from x to any node in its subtree in the centroid tree, and specifically to any black node. And then when we're processing the current newly marked black node, we process all of its ancestors. We update the answer with the minimum of the current answer, the distance from the current node to its ancestor, and the pre-computed best best distance from the ancestor to any of its descendants, and then we update that pre-calculated value. And basically the central tree has the height of only log n, which means that whenever we process a node, we are only processing log n things. So the total complexity is like n log n. Now this was such a bad explanation. I don't think anyone who, unless you understand centroid decomposition really well and already know these properties, I doubt you're gonna understand this, and I'm very sorry about that. Let's check my final standings. Do I end up on 8th or not? I guess I do end up on 8th. Okay. And finally, I will talk about problem G. Where to start? Okay, so you might have seen on my screencast, I did not understand what on earth this problem was asking. But eventually I did figure it out, even though the clarification did not help at all. There's so many. Oh, I guess jump was fixed to move, because they were using they were using like the terms move, turn, and jump, and then they were also using the terms piece and token interchangeably, and it was super confusing. I still have. Yeah, and then they got rid of this part, but not more than once per turn, because there is only one like turn in total. So there's only like one continuous sequence of moves. So this line did not make any sense to me. I'm glad that they took it out, but they should have done that way earlier, and I'm very annoyed about that. Okay, so this was actually surprisingly simple for problem G. I found this, I think on a conceptual level, it was easier to understand the problem F. So what does this problem actually want? So I'll just summarize the problem very quickly. The problem essentially asks us if we can do the following process. So the following process is, first we move one node we move a token to an adjacent vertex, and then if that token ended on the bonus, then you move another token, and so on and so on. So once you've moved the first, so like until you've reached node 1, every token that you move must land on a bonus tile. If it's not a bonus tile, then the thing terminates and you end. Okay. So something like, okay, there's first of all, there's only some candidates. So there's only some tokens that can reach node 1. So basically a token, like if we ignore the entire condition about like when tokens can be moved and stuff, the only tokens that we need to consider as candidates to reach node 1 are the tokens where, like, from its starting position, like let's say there was a token at node 3, then this would be valid. This would be able to reach node 1, and it's able to reach node 1 if there is a path from its starting place to node 1, such that all of the nodes on the path are bonus ones apart from the starting one. So for example, like this 7, this 7 is also good. Like this 7 is able to reach node 1 because I can go from 5 to 6 to 4 to 2 to 1, and apart from the starting position, every other token that I went on was a bonus vertex. So those are the only tokens that even have a chance of reaching node 1. And okay, so the first observation is, if we ever have two bonus vertices next to each other, and there's like a token which can like oscillate between these two vertices, and there is another token which can possibly reach node 1, then the answer is yes. And the reason is basically you get one token just oscillating back and forth between these two nodes, while the other token slowly reaches node 1. And yeah, there's only one other case where it's possible for the game to be won. And in this case, we have, since we've already covered the case where there are two adjacent tokens, like oscillating like this, now we can assume that there aren't any two adjacent bonus vertices, and all of the bonus vertices are stranded. And what this essentially means is that once a token moves onto a bonus token, you can't move that token again. Like, for example, if only nodes 2 and nodes 5 were the bonus token, if I was to move if I was to move this token on node 7 to node 5, and like let's say that like and these 4 and 6 for my explanation they aren't bonus vertices. Once I've moved the 7 onto the 5, I can't move this 7 again because none of its neighbors are bonus vertices. Which means that apart from the one token which must reach node 1, apart from that one token, I just have to see whether compare the distance from I have to compare the distance from that token to node 1 and compare that with the number of other tokens which can reach a bonus vertex in one step. Because like all of the other tokens, they can basically give me one extra move to move the desired token to node 1. And the way they can stall for time is just that as a one-off, that token can move onto a neighboring bonus square. Hopefully that sort of makes sense. And here's basically my code. So this is what my code does. First of all, I read in all the input and I mark node 1 as a bonus tile. Okay, loopable. Loopable means whether a vertex is a bonus one and it has a vertex which is also a bonus. So for example, node 5 would be loopable because if a token was at node 5, it would be able to oscillate between 5 and 6 indefinitely. That's what I mean by loopable. And then I perform a BFS, and the BFS is just for every node, if a token was on that node, how many steps would it take to reach node 1? If apart from the starting node, you can only move on to bonus ones. So that's just a regular BFS, except for if my current node is not a bonus one, then you can't let other tokens pass through it, basically, because it's not a bonus one. If there's only one token, then if that token can immediately reach node 1 in 0 or 1 steps, then the answer is yes, otherwise it's no. I just handled the one token case as a special case. Okay. Here's where I get to the logic of my code. Because like for a node to be able to oscillate between two nodes, it doesn't necessarily need to start on a loopable vertex. It just needs to be able to reach a loopable vertex in one move. For example, this node, like this token on node 7, on its first move, it can reach node 5, and then it can oscillate there indefinitely. So for a token, to check whether the token can oscillate indefinitely, we just need to check whether it's already on a loopable vertex or whether one of its neighbors is a loopable vertex. And actually, it suffices just to check whether one of its neighbors is a loopable vertex. So that's just what I'm checking. So for every token, if one of its neighbors is a loopable vertex, and this is what I need to check. I need to check that there is there's a different token in this. There is a different token which is able to reach node 1. And because of the way I set up my BFS, like I set my BFS distance to 1e9, a token can reach node 1 if and only if its distance is less than this infinity. So I basically need to check whether there's some other vertex, some other token which has a distance which is not equal to 1e9, i.e. it can reach node 1. And because I don't want to check every other vertex, I don't want to check every other token because that would be slow. The way I'm doing is I only consider the smallest and the biggest tokens. I only consider the smallest and the biggest tokens, smallest and biggest indexed tokens which can reach node 1, and then I only need to consider these two. I only need to consider these two tokens as possible candidates. The reason I do this is because, like this current token which is going to be oscillating, like the token I is the one which is going to be oscillating. I just need to check whether there is another token. There is another token which can reach node 1, and basically, because this could be one of them, I basically just need to store two. I basically just need to store two possible tokens that that could reach node 1, and if either of them is not equal to the oscillating token, then the answer is yes. So I need to check 2 tokens instead of 1, because one of them might be the same as I, and you can't have double ups, I guess. I'm just using big and small because it's a convenient way to get 2 tokens. And here is a vector called reach. Reach I is equal to 1 if and only if a token at node I can is adjacent to a bonus vertex. So node 3 is adjacent to a bonus vertex, so reach is equal to 1. This basically allows me to count the number of tokens that can reach a bonus vertex in one move. And what I need to essentially check is, for every possible token which might have a chance of reaching node 1, if the number of other tokens which have reach equal to 1 is big enough that the current node can reach node 1, then the answer is yes. So first, tot is the total number of tokens which can stall time by going to a bonus vertex. And when I'm processing a current token, so I'm processing a current token and checking whether this can be the token that reaches node 1. First, I will subtract the reach of my current token because only other tokens can stall time by going to a bonus vertex. My current token doesn't count time. And if this number plus 1 is greater than or equal to the distance, then the answer is yes. And for example, if there's 4 nodes if there's 4 other tokens that can stall time and my distance is 5, then it's possible because I just alternate moving the token and stalling time, move token, stall time, move token, stall time, move token, stall time. I hope people know what I mean by stalling time. Stalling time just means doing the turn by moving a node to a bonus vertex. And then if that's possible, then the answer is yes, and otherwise the answer is no. And the complexity is just O(n). Hopefully that wasn't the worst explanation in the world. I feel like the written editorial might be way clearer for this. So in the end, I did end up on 8th place, which I'm extremely happy about. Let me know what you think about this type of content, and maybe I'll see you guys next time.